Well, it's 11 o'clock, so we're going to get this webinar started. So appreciate everyone joining us today. We actually have quite a few people that have signed up and being a part of it. So this is going to be our webinar on new emissions dehydration, our new emissions dehydrator. This is a virtual roundtable, so it's not just us giving a webinar. This is your time to be interactive as well. To stay in the know with us, if something happens, I know a lot of people working from home, maybe on location. Don't worry, this video will be recorded, uploaded to our YouTube, our blog. You can do a quick search function onto our blog to find the questions that you're actually wanting to understand and know. You can find us on LinkedIn. There's actually a lot of other blogs, especially about this PDS product. We got a lot of other educational blogs that go along with it. So please check those out. So the people that we have speaking today, my name is Cameron Croft. I'm CEO of Croft Production Systems. We got our Director of Engineering, Chris Smithson, that will be joining us. And then Erice Gorka is our Service Manager. Everyone works here at Croft. Actually, Eric, you just had your 6 years yesterday with us?
No, it's coming up very shortly.
Okay. All right. And Chris, you've been over 10 years with us. So the topics that we're going to be talking about today, we are going to go over the origin story to get a better understanding of why we came out with this product line. It's actually a big portion of our business. It's not the only one. We're going to go over how it works, Desiccant Myths, the big emission controls, especially with the ESG initiatives that are going to be out there, and then PDS case studies. So this is a roundtable structure. With that being said, if you do have questions, especially if we're talking about a topic, this is your time. I have the question and answer and the chat function up. So I will be interrupting Gorka and Chris, getting in there, making sure that your questions are answered. So please feel free to write any questions that you have, so that way we can get it going. The big focus today out of all the pipeline spec, the contaminants that we're looking at is the water vapor, the dehydration portion of it. Now, the origin story, I'm going to talk a little bit about that because it actually comes from my dad, and I could riff on him a little bit stronger than most. But so what he did is he actually, he was a consultant. He owned multiple wells, and he was a consultant over 100 wells. So he owned and operated as a consultant. So they had a pilot light go out in one of the TG systems, and then when they relit it, you know, as most people do with a burning rag, and you shove it into it, it actually had a flame blowback onto it. Well, the guy that he was working with at the time kind of blew back on him. No one was hurt. No serious damage was done. It's nothing like this picture, so don't think it's that. But it did get to the point where my dad looked at the guy turned around to him and said, there's got to be a better way of doing this. At that point, my dad actually trying to find a better way of dehydration where it didn't require burners, pumps, all the headaches that actually go along with it. He started looking up, and he found a 1920s, 30s technology that allowed this capability to happen. So he started building his own. As you can see, this first generation picture in the middle here, this is the best picture I could find. It had guide wires. The other ones are about 20 foot tall. They're leaning tower of Pisa, and trying to service those things, because I was 16, 17 years old trying to fill these things. They were god awful. They were rough to deal with. You had to get 5-gallon buckets, hook it, drag it up there, fill it up. So since then, that was our first generation, but it proved that it worked. They were reliable, easy to maintain. So he put them on all of his locations. And then being in the oil and gas industry for so long, he had a good credit that other people started asking him. And then at that point, he said, well, this could be a business. So we went into business at that point. He sold off a lot of his locations, and he went fully into the production processing side. Now, since then, on the right side, we have our lease fleet in 14 states now. We sell equipment nationally, internationally. So it kind of went in from a big expansion from there. So it's kind of neat that, you know, from one blowout on a TG pilot, it's changed his career path. Now, kind of turning it over from there, it's not just dehydration that we go on. There's multiple niches and facets of the market that we're in. Chris and Eric, can y'all talk a little bit about these pictures, the varieties that we've been in?
Yeah, and this is a kind of a sampling of the different units that we design and build. The center one, the small little 10-inch vessels, like the smallest of the dehydration vessels that we do for the PDS units, and then all the way up to our large 60-inch vessels, which we can manifold together multiple ones to handle volumes. Right now, we're putting in a system for 200 million a day to handle that as a polishing unit for a pipeline. But like a little one that can handle 10 MCF a day, and anything kind of in between with the different configurations of them. We've also made some trailer mounted units for mobile applications for fuel gas or temporary dehydration.
Yeah, so there's different varieties. The trailer one was that was a fun project, and we're building multiple of those. So yeah, talk a little bit about that.
Yeah, the trailer one, that was an interesting fuel gas project. Up north, the gas quality is really good, can be used directly into natural gas powered engines. So they just need to make sure that it's dry so that when they run it through the regulators, it doesn't freeze up. And so these units were designed for drilling rig fuel and dual fuel frac spreads. So the trailer would be brought in, it would clean up the gas to power the generators for the drilling rig, then the drilling rig would leave and the frac spread would come in, and then we were dual fueling the frac spread to displace diesel costs, and which is a great way of saving a lot of money on diesel. But these systems work really well for fuel gas. Our turn down on our PDS systems is 100 to 1. So a system like that trailer unit that's good for maybe $1.5 million worth of fuel gas can turn down to 10 MCF and still work great. They can turn off and on without having to restart any burners or pumps or anything like that. So for temporary and intermittent applications, they work really well for dehydration.
Well, let's go into how it works. Yeah, Chris, if you can kind of take the lead on that, and then Gorka especially on the service side, because you're the one that has to chew on it most of the time.
Yeah, so the basic function is we're filling up a vessel with a dry pellet, and so it's a pellet. It's about the size of a large almond, and it's made of a mixture of different salts. It's not table salt. There's a little table salt in there, but there's different kinds of salts, and all of the salts like to absorb water. The kinds that we use likes water more, but it's basically we're sucking the water moisture out of the natural gas with these salt pellets, and the salt is going to absorb that water. It's going to start dissolving the pellets, and it's going to collect as a brine water solution in the bottom, and the gas basically comes in the bottom wet and leaves the top of it dry. Now the product that we have is formulated to output about 2 to 4 pounds at higher pressures. And so when the gas comes in at whatever water concentration it is, it's going to leave at around 2 to 4 pounds per million of water leaving the system. And basically, it's just going to keep eating away at that dry bed of product. It's going to just keep shrinking down as it gets eaten up. And then the service team comes and they refill it, normally on a 30-day service schedule, to just top it off as however much is needed in there. But they're very simple systems. There's nothing to turn on or start up or really anything. As soon as the gas starts flowing through there, it goes through the system. Basically, once you've purged out all the gas out of the system, you're drying. And it's very quick, very simple systems. And as long as you have EnviroDry in there that hasn't been contaminated or anything, then you're going to be drying your gas.
Well, actually, yeah, talk a little bit about the sizing portion of it, and then what are the steps that you need to actually size one of these systems?
So for sizing, we look at two things. We look at the volume that we're going to size, and that's going to dictate the diameter of the vessel. So we want a certain velocity going through the system.
Mm-hmm.
So we're going to, if it's a real high volume, it's going to be bigger vessels, maybe a couple in parallel. And then the other thing we size for is the runtime. We like to size for a 40 to 45 day runtime. That gives a 30-day service cycle, a little extra wiggle room in case they need to come in there to be able, to get delayed a week or something. So that runtime basically determines how many vessels we're going to have.
Mm-hmm.
So a single vessel may get you to that 45-day runtime, or if you have a little higher EnviroDry consumption, then you need to add a second vessel. and you'll have, you know, one or two, maybe three in series where it runs from one to the next, and slowly eats it up. So at the end of the month, you may have your lead vessel completely empty, but your second vessel is mostly full. You're still meeting spec. They come and they refill the first vessel. So that's basically the way that we size it. We diameter gives us our volume, our velocity, which is based on pressure and volume, and then the number of vessels gives us our runtime.
Awesome. You know, on the service side, like how it works, kind of walk us through what your service techs have to do on location.
Yeah, absolutely. So like Chris was saying, every one of our units in our service area are on a 30-day service cycle, and they're simple to service. So when my guys show up on location, first thing they do is they'll go through the instrumentation, make sure all the instrumentation on the vessels is working properly. If there's any kind of hiccups, we fix it there. And then from there, we check the product inside the vessel.
Mm-hmm.
And so we'll bypass the unit or switch over to another vessel, so you always have dry gas. We'll open it up and we'll check the product inside and see, you know, if it needs to be refilled. You know, we'll use our crane trucks and we'll refill it. Sometimes we'll show up to location and the gas has actually made a little channel through the product. So we'll rod around, get the product broken up, fall into that channel. If it needs to be refilled, we refill it again. Like Chris was saying, they're very simple units to service.
That's awesome. So let's go deeper into the actual desiccant itself. I know earlier you were talking about some salt product being in there. We have a lot of clients that just call them salt beds. Mm-hmm. So can y'all explain a little bit about what it actually is in EnviroDry, and that it is salt, but not everything is salt?
Yeah, so it's a mined salt that's refined. And it's mixed with a couple different kinds to give us the blend that we're looking for. Mm-hmm. And we also have it shaped to what we feel is a really effective shape to reduce things like channeling and bridging within the system. So and that gives it kind of like an oval shape, round pellet that the gas will go through. The real benefit of it is that it really only wants to absorb water. So that's the only thing that's going to dissolve the actual salt is water. We've gotten slugged completely with oil, and we just have to drain the system out and it's ready to dry again. That's not going to actually dissolve the pellets unless there's a bunch of water in the oil, then you're going to actually have some of that dissolved. But it really is just looking for the water. So if the gas is coming in partially dehydrated, then it's only going to react to however much water is coming in there. So your consumption is completely based on your water into the system. So if your volume gets cut in half, your EnviroDry usage gets cut in half. If your temperature gets cut in half, your EnviroDry usage will get cut in half. So it's very simple in the way that it works. And the brine water, it's chemically similar to produced water. It has the same salts in it, just the higher concentrations of maybe one over the other that you're used to seeing. But it goes to disposal wells just like normal produced water is. And the amount of water that it turns into is the amount of water that you're removing from the system. So when you think of 60 pounds of water per million, that's not a lot. You know, that's less than or there's a couple gallons a day of water. So you're not talking about barrels and barrels of water getting produced off of this thing from the salt. And 1 pound of our EnviroDry will absorb over 3 pounds of water. So it does absorb it absorbs more than its weight of water, you know, times 3. So it does hold quite a bit of that water.
Hey, Chris, I also want to say it does. It reacts really fast. Also, I mean, as soon as you put the product inside the vessel, it's drying immediately. You can just hold it out in your hand, out in the atmosphere, and that product, you can see it start sweating and it's trying to pull the moisture out of the air. So as soon as you open that drum and you put it in that vessel, you're automatically start drying gas. It's a very quick reaction.
Well, that's the funny thing. It's like when we're first training service techs to come on, and you see them trying to wear leather gloves in the beginning, and you're like, no, you can't wear that, because immediately it just starts, the leather just shrinks up everything. You see their hands.
Oh yeah.
But even their boots, right?
Oh yeah, absolutely. Yeah. Some of the powder, like in this picture in the left, the boot there, some powder will get on your boot, and if you don't happen to wash that off as after you're done, your boot will curl up because it will start pulling the moisture out of that leather and shrink your boot.
Yeah, you had one of your guys, right, that took it off and then he didn't wash it off, so it just crinkled up like Wizard of Oz, the
Yeah.
witch coming back up.
Oh yeah, absolutely, yeah. And one guy even tried to put his boot on a 2x4 and nail it down to try to straighten it back out. I mean, it definitely pulls water.
Yeah, no. Well, the other ones, so I know we've used other chemicals in the beginning, especially when my dad was trying to test out the different ones. The big issue that he found that's why we started we manufacture our own blend now, because the first ones it was the binder issue, right? There's like 20 to 25% binder material in it, and that sludge would just sit on the bottom.
Yeah, one of our competitors to get to keep it formed, they added a something that's not soluble in water, basically, to help pack in and make their pellets stronger. That material though doesn't dissolve in water. It just turns it's powder, and can build up in the bottom and harden into places it shouldn't. Ours is a pure salt product, and it's it may cost a little more, but we know what's in it. It's not some stuff coming out of China or something with a bunch of random other things inside of the mix. It is a good product that we keep to our quality control and everything that we know is a good solid item. There's other ones out there, then there's different grades of salt. Like our standard EnviroDry is the basic product that we use in 99% of our units. We have a more advanced version, which is a different salt blend for lower pressure applications that need to be able to reach a lower water content. But it is a lot more expensive. Our standard EnviroDry normally works for all of our applications, for gas drying and for liquid hydrocarbon drying as well.
Yeah, the liquid hydrocarbon, because we're on quite a few propane projects right now where it's in liquid form. So that's actually pretty neat that this product we can use in the gas and in liquid form. So it's cool.
Same vessel, same EnviroDry. It can it just dries hydrocarbons. You can run diesel fuel through it, and it'll take the water out of the diesel fuel as long as you get your velocities right on the vessel, so that the water separates out from the hydrocarbon. But yeah, it just wants to absorb water, and so I mean, there's things that can contaminate it.
Yeah.
Soaps, surfactants, those sort of things. They can actually anything that's going to physically coat the pellet, it won't allow it to absorb anymore. But it's the same sort of things you want to avoid with the glycol unit. You don't want soaps getting your glycol unit because then you're going to foam out your tower. We don't want soaps in the EnviroDry because it's going to coat the pellets and not let you absorb. So it's similar issues, things you'd really want to avoid. And the glycol is the same things you want to avoid coming into our PDS systems.
Well, Gorka, on yours, like when you train your guys to go out to location and you're servicing the systems, how do you know that the system is being contaminated?
It's a real simple test that we do. Well, at first, we'll pull water content tube, and we'll see what the water content is. If it's high, open the vessel. If we see the vessel's full, it kind of gives you, a heads up that something's not working properly. And then from there, we'll pull out a sample of the product from inside the vessel and get a cup of water, fresh water, and you can put a pellet in that water. And if there's any kind of contamination, that cup of water is pretty much going to wash the pellet, and the contamination floats to the top. There you can see, bubbles from soap or oil sheen that has covered the product, something like that. And that's when we know it's contaminated.
It's also, I think, a discoloration. What happens when we start seeing a lot of yellow, like the yellow coating over there? Is that the liquid hydro, or what is that, Chris?
The scavengers,
Okay.
liquid scavengers. Because our vessel velocity is very slow going through the system. So whereas like a glycol tower may have a 12-inch tower, we'll have like a 24-inch vessel. And so our PDS vessels are typically larger diameter than an equivalent glycol tower, just because we need a certain velocity going through there. But because it's so slow, it kind of acts like a separator. So if we have H2S scavenger being injected ahead of the system that didn't fall out in the separator, it'll probably fall out in the EnviroDry, and it just kind of sits on the pellets, and you'll see that yellow discoloration on them. It won't necessarily stop us from drying unless there's something in the scavenger, or it's just so much scavenger that it's just coating the pellets. Normally, just the process of the pellets absorbing like they're supposed to, like the contamination gets stuck on the bottom. Like small amounts of contamination we can live with. It'll get stuck on the bottom, and the pellets dissolving above them will help wash them off. And like a short spike of contamination can usually get cleaned up by itself. Like the normal usage of the unit, it won't need an entire washout. Which is if the full product gets contaminated, we just got to dissolve it all with water, empty it out, wash it out with a pressure washer, and just refill the whole system again. Which, depending on the size of the system, can be a bit expensive to do a full refill on there. But yeah, the biggest concern that we have as far as contamination is surfactants. So high detergent compressor oils that's a place we see soaps coming in. Soap sticks, not so much. They tend to fall out pretty early. Capillary tubes where they're doing like a liquid surfactant, that stuff's a little more pervasive. Like it can make it through some separators if it foams hard enough. But that's usually the compressor oil is usually where we're seeing the main introduction of soap. But I mean, you can just change your compressor oil on your compressor side and avoid that.
No, that's good. And I'm going to move on to the pros and cons. These are the quick highlight pros and cons a little bit. So Chris, can you mind going over them?
Sure. Yeah. So main pro, it's very simple. Basically, open the valve, flow gas through it, you start drying. Usually it's like 15 minutes before we pull a tube just to make sure all the gas gets out of the system. Normally we're around 6 to 8 feet per minute through the vessel. So it can take a few minutes just to get through our PDS vessel. But yeah, they're super simple. It's really just the vessels ahead of it, and then the dump system on it to dump the liquid off. There's no burners, there's no pumps, there's no temperature controllers, there's no back pressure regulators, there's no low pressure separation systems, there's no filters, unless you have a coalescing filter ahead of it. But yeah, the simplicity compared to a glycol unit is night and day. I mean, we have, the simplest of our systems is just a single vessel with a dump timer on it and a dump valve versus a glycol unit with all its pumps, controllers, and everything. The lifespan of the vessels, it is just a solid high pressure vessel. Like our entire lease fleet is 1440 pressure rated. So they're good 25, 30-year life vessels. Even though we do have salt inside the vessels, we do not see excessive corrosion inside the systems. We do periodic UT testing depending on the life of the vessel, how long it's been in the fleet. And that salt does not have any sort of excessive corrosion inside the systems. We use standard carbon steel vessels and we don't see any problems. I mean, obviously the big problem is if you have oxygen coming in, but that shouldn't be an issue, or else you're just going to corrode out everything anyway. Excellent turn down on the PDSs. 100 to 1 is what we say. I mean, really it's higher than that. Just normally people just don't run higher than 100 to 1. It's completely dependent on the amount of water coming in. So you can have 1 million a day running through there and then drop down to 1 MCF, and you'll still dry effectively through that system, and your usage will be based on 1 MCF. So there's excellent turn down on the systems and great on off. Like if you have a well on an intermitter and you're shut down for 3 days and you turn right back on, and you have the intermitter that's controlling that, our unit starts drying immediately. As long as you didn't shut anything down or anything, you can just literally just turn the thing on and off and you will be drying immediately. There's no pumps to restart, no circulation to establish, no risk of throwing a bunch of glycol out of your tower because you just reestablished flow. So yes, excellent turn down, excellent on off. And then the emissions compared to a glycol is huge difference. The only emissions that we have is when we depressurize the vessel to refill it, which is minimal just based on the volume of the vessel, and the little bit of gas that gets lost on the dump system. We operate timer dumps instead of a typical level controller, and what that is it's opening a simple pneumatic dump valve for a couple seconds every couple hours and just releasing any liquids that are in the bottom of that. It doesn't know if it's liquid or gas. It's just going to open for that couple seconds. So normally we get a little slug of gas behind the drain line, which we prefer because it shoots all that liquid all the way to the tank.
Right.
But yeah, that's really our only emissions on a standard glycol unit with no BTEX. That's a 99% reduction in emissions. Now, if you have a BTEX, then cut that in half. If you have a BTEX with a combustor, then you're getting a little closer. But we have no CO2 emissions. I mean, it doesn't matter how good your BTEX is, you still have a burner on your glycol unit emitting CO2. So our systems, we put them in Pennsylvania without air permits, put them in Colorado, Wyoming with no air permits. We've put our systems out just because they can't turn on a glycol system, because they can't get the air permit for that system. So yeah, it's minimal emissions with compared to a TG system. If you put manual dumps on it, then you don't even have the drain line emissions. The cons for our system, it is a higher capital cost for a base glycol versus a PDS system. If you go full out on a glycol unit, BTEX, BMS system, the controllers that you want, maybe some telemetry stuff, you're going to be more expensive than our system. But just the base, like a base glycol versus a base PDS system, well, PDS is going to be more expensive just because it's bigger, heavier vessels on there. The other con is our cost is linear with volume. So if you double your volume, you're doubling your EnviroDry usage and you're doubling the size of the system that you need. Compared to a glycol system, they start to get, the bigger the vessels get, you get some economies of scale there, where the cost starts to drop down. Glycols are regenerative, so on the really big systems, you don't have the same cost that you do. As the smaller the system gets, it doesn't necessarily get cheaper on a glycol. Versus a PDS, it is linear, so you are basically doubling if you're doubling your volumes. The other con is with our standard EnviroDry, below 300 pounds, we're not going to get below 7 pounds per million, which is typical pipeline spec. There's a more expensive product that we can use that can get us down at lower pressure, but it is very expensive. So typically that kind of puts us out being able to use that. But yeah, normally as long as we're over 300 PSI, then we can meet 7 pounds per million on the systems.
Well, on the cons, Gorka, I want you to kind of expand on that, like not really cons, but how you said very simple operation. So your service techs, what do you demand from them? I mean, if it's simple operation, how many units can one of your guys handle?
So depending on the logistics of the units, most of each one of my guys is in charge of a route, and they're supposed to hit that every month, every 30 days they hit it. And depending on the logistics, you can hit, just for an example, we have about 20 units just in the Livingston area. And in 2 days, all 20 of those units can be hit and serviced properly. Now, when you start spreading things out, it gets a little more difficult. Our biggest problem to get to the units is actually getting to the units, the drive time. We're especially in East Texas, we're on the other side of Houston. So if you hit that Houston traffic, then you're just sitting there.
I mean, 18 miles on a dirt road and 5 cattle guards and the 3 cows that are in the way, that doesn't slow you down?
Hey, well, I'll take that other than driving downtown Houston at 7:30. No, yeah, each one of my guys have about 25 to 35 units that they're in charge of hitting a month. And that's what we have right now. We have them sectioned out. When I first started, we were looking, there wasn't, I think there was 2 of us, one in East Texas, one in South Texas, and I had more like 52 to 60 that we were hitting a month. I mean, don't get me wrong, that's booking it. But yeah, it's very simple. If everything checks out, you're looking at maybe an hour to properly routine service a unit, check everything out. And that's filling out the tickets, filling out your JSA, everything there. We call the clients and kind of check in with them. That's, having a conversation with them. Usually it's not a 30-second conversation. It's 5-10 minutes, just kind of talking with the client, seeing how they're doing, if they need anything from us. So routine service, about an hour for each unit.
What's the biggest issue that y'all see out there?
So the biggest issues that we see, it actually comes in the drain line. We ask operators or pumpers to check the drains daily. And then some drains don't have to be checked daily, depending on the volume. But if they're not checked frequently, then there could be that's pretty much the only moving part on the PDS is the dump valve that actuates. And I mean, that's a solar panel, battery, timer box, and a dump valve. And if something, just a hiccup, just a small hiccup, and the salt doesn't have anywhere to go, it will get plugged up at the bottom, and that will lead into bigger issues. But if that drain line is constantly checked, and that brine solution is constantly being dumped out, then plugging the drain line is usually not an issue.
Like if it does get plugged up though, I mean, how big of an issue is it for your service guys? What do they do to clear out the drain lines?
So if the drain line does get plugged up and we catch it in a reasonable amount of time, what we each one of our service trucks is issued a pressure washer, and we'll hook into the drain line. We literally flush out the drain line. We'll flush out the bottom of the vessel in case any of the salt is solidified at the bottom there. Rinse out the bottom, and it's simple as that. It's salt. You put salt and water and it dissolves. So as long as we catch it as a reasonable time after it happened, you're talking 5-minute fix maybe, and that's actually flushing it completely full, completely the bottom, flushing it a few times and draining it. What we've got in the habit of doing, if we happen to see units that do get plugged up more often, then we will add water to the bottom. I mean, you're talking a couple feet from the bottom of the vessel to actually the product bed, and we'll leave water in there. So when the salt drops down, it hits fresh water and then, dissolves in the water that we left it, and then it gets drained out. If it comes into a bigger problem, we offer water injection skids at the bottom of it just to keep constantly pumping fresh water in there. Usually something like that happens is with real high temperatures, and we're moving or going through a lot of EnviroDry.
Well, that actually is one of the questions is saying, how come we don't have level controllers just put into the unit, running the dump valve that way? Why timer boxes?
So with the level controllers, what we found out is, I mean, it's salt. So you have the level controller arm in there, and the salt will grab the level controller. Sometimes give you false readings because it will clump up on the level controller and activate it to dump or not dump. Also, salt can be corrosive on the level controllers. So it's just, in my opinion, it's simpler. We set a timer and we can adjust that timer. It doesn't have to be every 2 hours for 4 seconds. That's pretty much what our default is when it goes out to the unit. 2 hours every 2 hours for 4 seconds it dumps. We have units that are real low flow, cool temperatures. We dump them once a day, and we don't see an issue with them at all. But with the level controllers, we just there's a lot more hiccups than it probably should.
Well, it goes into the kind of leads back into our desiccant myths. Now, these are the 3 main areas that we see a lot of, because we get a lot of clients where they're saying, well, I've dealt with these salt beds in 1970s, 1980s, and this is what I have. So what, in dealing with these desiccant myths, Chris, do you mind reading these off and then kind of your rebuttal to these myths?
Yeah, so like the first one you hear a lot is they're only really good for low volumes, and part of that is because the biggest market for these was fuel gas. So and if you haven't seen ours, but you've seen somebody else's desiccant system that uses a consumable desiccant, what you've probably seen is a little small fuel gas cylinder on like a line heater or GPU or something like that. And so that kind of, people really thought they didn't want to change them out that often. They just weren't really a little more unsure of them. So it just kind of gave rise that they were really only good for low volumes of gas. Like the picture here, that's a pretty good example of what we've put a lot of our systems in, where it's a pretty small glycol unit, but the volume gas just wasn't worth operating the glycol units. They just kind of like shoved it back 2 feet and put our vessel right there where the tower was sitting, and then piped into it. And which is great for small volumes, but we've successfully dehydrated over 100 million. We can handle much higher volumes of it. That is usually for shorter term applications, maybe 1 month, maybe 6 months for those, because at the really high volume rates, Depending on your inlet water content, if you have like high temperatures, a lot of water coming in, then a glycol is going to be a more cost-effective option. But for temporary applications, we can handle really high volumes. We did a temporary one for a pipeline polishing application where they were doing a chemical wash on a pipeline, and we were doing 20 million. And we have 4 other applications up north where we're doing 20 million, and those are permanent applications because the temperature is low that's coming in, pressure's high, low water content, low enviro-dry usage, and they just make sense as temporary or as permanent applications. For them, they've been out over a year. They're definitely going to be out there for at least another 2. We have one site that does 60 million up there as well, where it makes sense from a inlet water content perspective. But yeah, we can definitely handle high volumes. It's just a matter of scaling the vessels. And we our big 60-inch vessels can handle easily 10 million by itself, and you put a couple of those together and you can get to whatever volume you want. The other thing is that the desiccants are only economically feasible at lower volumes. And really that goes back to how much water is coming in, because we're only removing however much water is coming in. On a polishing application where you need to do 20 million and you need to take out just that little bit because your glycol is acting up, or you're 10 miles away from that unit and you got a little water in your line that's drying out, we can be very economical at high volumes. It really, colder temperatures with a lower water content, we're easily cost competitive with the glycol system. It's when you get into the really hot temperatures, lower pressures, where you have a lot more water coming in, that we're not necessarily economical for those options. But just the volume isn't really an indicator of whether or not we're a good fit for that system. And the other thing is desiccant systems can't dehydrate gas at a higher flow rate. We can handle whatever volume. It's just a matter of slowing it down enough in the vessel. So as long as we're properly sized, we can handle the higher volumes and dry down to 2 to 4 pounds, just like we would at the lower volumes. So yeah, we can handle the higher flow rates and it perform to the same expectation that we can with the lower volumes. It's just as long as our systems are adequately sized for it.
Yeah, we're on several midstream stations right now doing 20 to 40 million a day. This other project we're working up in the Northeast are doing 160 on one location and 200 million on the other location. So I don't know, but these are the myths that, especially in the beginning, Chris, you were this, like my dad, even when we were going, I said, we got this application, they're wanting 10 million. And even he goes, no, everything I read, you can't do that. You can't do that much. But we worked with the client. We said, all right, we'll build it. We'll size it properly or to the best of our ability, but we'll have to try it out. We don't know. And then we did the 10 million, and then now we're up to 200 million. So we were even believing a lot of these, the myths that were going into it, or the paper case studies from the past. So it's kind of neat to see how, I'm glad it proved right. That's fantastic.
Yeah, and what people know is what they've read in like GPSA handbook or maybe some textbooks or something, but all there ever is a paragraph about our systems. It's an old technology, 1920s when they first started using salt to be able to dehydrate. Obviously, we have our own proprietary chemical blend. We know how to design the vessels for that. And maybe we've never been asked to contribute textbook, but like the information in there can be a little misleading. Some of it, like the sizing recommendations, the volume recommendations, what it's saying in those textbooks doesn't really do justice to what we're able to do with our systems. So it kind of gives us like, we talked to some engineers and they actually did some research, but it's kind of tainted by this, something that somebody read, and it's one textbook referencing a next to a next to a next that is from 1970, and it's the same paragraph just retyped. Or they're used to the old, Desi-dry systems, NACO, and they were just inherited it, and they had no idea, how the thing was supposed to work, and it got ended up putting into a situation where they had a big mess up on the system and nobody to help them troubleshoot it, and so they ended up hating the system. Or they had a boss that's all he knew because he had a horror story from the 80s, and then so their impression of them isn't that good.
Yeah.
But that's one of the hardest things that we have to fight is, just the impression that people have from using some other system from 40 years ago.
Well, that's what I want to do is go into the methane emissions, because that's one of the key trends that are actually happening right now. Is everyone's pushing for ESG, the environmental and social governance programs, the initiatives. being Paris climate agreement, we're back on schedule on trying to meet. So I started trying to do some research on ESG, figuring out how are people even gauging the initiatives that they need to focus on. They kept on referencing the EPA. So looking at the EPA, and the EPA, if you believe the numbers or not, but this is what that they're pushing out there, is that 12 billion cubic feet of methane being released from dehydrators and pumps. Now, pumps, in what sense? I don't know. Is that the pumps on the TG, or is that chemical injection pumps? They're not really specifying. But I wanted to bring that to the attention of, this is what everyone's having in the back of their mind. So politicians, regulators, people that are legislating, this is what they're seeing of what they need to be focusing on. So whether it's right or wrong, this is what they're starting to believe. So I did want to, now we do build TGs, we do recertify them, we service on them. So I want to talk too badly about them, but I do want to go into the aspects of what are the issues, the inefficiencies from them. So Chris, can you go into that, and then Gorka kind of on the service side?
Yeah, so the emissions from the glycol systems, all the bad stuff comes out of the still column. The burner is just a burner; it's just burning the gas. I mean, you are the efficiency of the burner, be it 95, 98%, whatever that kind of that style burner is. I can't remember offhand, but so you do have a little bit of methane emissions from that, but overall, that's not necessarily a big number. I mean, you do have your fuel usage, equivalent to your burner, and your circulation rate, what you're running, can be kind of high. I mean, you could have 5, 10 MCF a day, depending on the size of the glycol system that you're just burning, and then say 2%, 3, 4, 5% of that, methane just getting emitted because it didn't get full combustion. But the main emissions is coming off that still column, and that's assuming your flash separator is, if you have a flash separator that's going someplace safe. If you have a flash separator, you have a lot of methane that's getting emitted off of from your pumps, but all the bad stuff is in the still column, because it got captured by the glycol. Your benzene, your toluene, your ethyl benzene, these are all hydrocarbons that are in the gas. Glycol likes them, so glycol grabs them in the tower, takes them to the still column where they get boiled out. And benzene, toluene, that's basically paint thinner. So it's a hydrocarbon, but it's just heavy enough to be in the, or it's light enough to be in the gas, but heavy enough to where it gets captured by the glycol. And so when that gets boiled out, if you don't have a good BTEX unit to capture those, remove them, send them someplace where they're not going to, just vent off to the atmosphere, like a combustor, or liquefy them into a tank, then you have an emissions problem. The standard glycol, or the standard BTEX system, just the ambient cooled ones, where they're just doing that, those are just liquefying what they can. They're cooling down enough to where they can try to liquefy that, but that's not going to get all the BTEX out of there. Then you have your vapors, so you send those to either your burner, or you send them to a combustor. Or if you send them to the burner, they only combust when the burner is on. So all you can really guarantee is a 50% combustion on the vapors that are coming off that BTEX unit, because the burner is only on half the time according to the EPA. But so you send it to combustor, you get a lot better combustion, but then you're just turning into CO2. So you never really get away from that emissions. No matter how good your emission control system is, you still are going to have some off of a glycol unit. I mean, you can go electric reboiler, but then you still got to burn something, unless you're capturing and sending it down hole somewhere, which I haven't seen anybody try yet. There's really no way to completely have an emissionless glycol system. But yeah.
Well, I know they're getting close. Like even right now, we sell a lot of upgrade systems, because people already bought the asset. Now with these emission controls coming up, they're trying to hit their initiatives. So I know we have like burner management system upgrades, trying to increase efficiency, better BTEX systems, better burner tips, so you don't get the NOx, and the better mixture of the airflow in it.
Yeah, there's a lot you can do to help get a glycol system to operate better. I mean, I'm a huge fan of burner management systems on them. One, from a safety aspect, because you just hit on and the thing turns on. You don't know burning rags through that open port. but also because it turns off when the flame burns out. I mean,
Right.
any operators relit a pilot before, had one blow out on them. You know, what if you can't boil your glycol, you're not dehydrating. So, you know, the fact that those things can auto relight, and if they can't, they just turn off, and you're not just venting gas, because a standard T12, this is going to open up. That thing's going to just keep sending gas to that burner. So your fuel gas goes from, you know, 5 MCF a day to all of a sudden you have 40 MCF lost for the day because the pilot light blew out and it was just spewing fuel gas into the burner. So yeah, there's definitely upgrades that you can do to try to reduce those emissions, and they're all, you know, I think they're all beneficial things from a safety aspect and emissions aspect. That if you can, you know, put them in there, upgrade to BMS systems, you know, we'll get a good BTEC system. But yeah, it's just you'll never get 100% of it for the glycol system.
That goes into the big push for our glycol systems being replaced with our Desiccant RPD passive dehydration system is the simplicity, the air permit issues, and people don't want to spend the money on the upgrades that they're seeing. What are you saying on that? Like, explain what are y'all seeing from your clients, especially with the ESG initiatives?
Yeah, we see a lot of replacement of oversized systems. So systems that were initially sized for an initial flow rate that declined after 3 months and is no longer anywhere near what that big unit was designed for. We see that a lot. A lot of our clients are like the second or third owner of the locations. So the original glycol system, maybe, you know, getting 10 years old, insulation's fallen off, it had a small fire. You know, they don't want to spend the money to fix it. So they can get our unit designed for smaller volume to just completely replace that system. You know, maybe they can take that asset, they can put it somewhere else more usable. You know, they can take a dehy size for 20 million and put that on a new well pad or something, and the small, you know, this old well pad can get our rental system that they don't have to worry about. You know, we have a lot of operators that love our units just because, you know, they show up and, you know, pipeline says, hey, you know, you're reading a 7. They're like, okay, they call Croft, you know, they call Eric and they sends one of his guys out there. They don't have to deal with it. There's no pumps to change. You know, we'll be there. Maybe they switch over to a vessel that's in bypass so that it'll bring them back into spec. And, you know, we show up a week later, you know, there's no rush to fix it. So a lot of it is, you know, replacing equipment that's either way oversized, where it just can't dry, or it's just not worth fixing for them. And the other big thing is permits. You know, they don't want to wait on a permit, or their flow is going to be changing so much. This one where the tan vessels where they have snow on them, the decline, it's shale production up in the Marcellus. The decline after 3 months, the production's cut in half. So what their plan was, they're just going to take one of these vessels, peel it away to a new site, and they're just going to eventually leave just one of these vessels there to handle that. So they're able to mix and match as needed for the production volumes. And because it's up north, you know, cold temperatures, low water content, their enviro-dry uses were so small that we were way cheaper than a glycol system for them to operate that way. Even though you have physically move these things every 6 months, you know, package up 5 or 6 of them together on a new site to handle an, you know, initial flow rate of 60 million or whatever. And then, you know, once it drops down, they, you know, peel off a couple and take them somewhere else. You know, that can be real beneficial for them. And you're not waiting around for air permits, and you know, you can just get that, you get them online immediately.
Well, one of the questions that we got is to ease the simple operations on the PDS, would it be helpful to know that if you're dumping every 2 hours by status alert? So kind of like a monitoring, would that actually help out?
The systems are pretty simple, and Gorga, you can probably talk a little more to it, but like when you were talking about just checking to make sure the dumps are dumping, you're talking about just going and pushing the button on the timer and watching that dump valve go up and down and listening or maybe feeling the pipe to know that there is something actually flowing through it, because that's what we want the drain to actually dump. Like, we want liquid flowing through there. If you go hit that on button, that valve goes up and you actually hear gas shooting through there, you're good, because you know that it actually is dumping the liquid off of the vessel. I mean, there's like clamp-on sensors that'll tell you actual flow through that. On a bigger system, it'd be nice to have a a remote monitoring type setup for the dump system. This picture with the tan vessels, actually, they didn't have our timer dump. They actually programmed it into their control box so that they could remotely dump it if they wanted to. What they never did was put on any sort of flow sensor on the flow line to make sure that it actually was draining to the dumps. It didn't really turn into a problem. Because I guess it's another thing to bring up. Gorka, we have almost 100 units in the field. How many drain lines do you break clear a month? Like out of all those, how many of your guys are actually pulling that pressure washer out to break a drain line clear?
Maybe once a month. I wouldn't even say that.
So one, maybe 2 units a month out of the 100 or so need their drain line cleared out.
Maybe that's maybe, and we either see it also when the temperature is really hot outside in the summer months where the gas is hotter and it's using a lot more product and it's falling out, or in the colder when it gets real cold and it's sitting there for a while and it's cold outside, and it just kind of helps it speed the solidifying process up. But like I said, maybe once a month, maybe. And then if we see if it's a recurring issue on the same unit, one of my guys will sit out there and, for a whole day and play with the timer box. If we're dumping every 2 hours, he's going to sit there for 2 hours, have an alert on his phone or watch, and go there and watch it dump. And if we'll listen, like you mentioned it earlier, right at the very end, we want just a hair of gas to come through and push that. So if it dumps and we don't hear any gas, okay, well then, we'll set it for an hour or we'll dump it till we hear gas, set it for an hour, 30 minutes, and then wait for that gas, kind of play with it to see, what's a good time. We have a unit, very hot gas. We've tried to cool it down. We just can't do it. It dumps every 30 minutes. It just makes that much fluid. But as for actually plugging up pressure washing, maybe once a month, and it's not that bad. I do want to say in that left photo that we're looking at there, we're talking about switching out sizes. That vessel has actually been switched out. We replaced this TEG because it was too large in the background there, and we had, I want to say it was a 3-bottle unit, and the volume kept dropping and dropping, and now we have a single bottle unit out there. It's very, I can't explain really in words how simple the units are, that we can just switch out units in, out, drain, three pipes that come in and out of it. And it's very simple, but yeah, I just wanted to hit on that real fast.
Yeah, well, that one was changed out in what, an hour? The crew had it piped in, and we were drying gas through the single bottle, and then they yanked the multi-bottle.
Yeah. In that picture, the multi-bottle was literally right to the left of it. So they hit some unions off and piped that one in.
To stay on schedule, we're going to skip a few things. I think I got a little ambitious with the presentation, so we're going to go into the case studies. But before we get into the case studies, we do have a question. This is, where do you take the brine water once it's dumped?
So the brine water is chemically the same as produced water. So we just normally send it to the saltwater tanks on location. It doesn't add any there's no special disposal requirements or anything. You can't even tell it's mixed in. It looks exactly like produced water. So it just goes to wherever the disposal, the water is going for disposal. Here in Texas, there's always a saltwater disposal well that, it's going to go to, but most sites have they'll have a saltwater tank, oil tank on site, and we just pipe into that. Normally we like our own dedicated drain line all the way to that tank if possible. Really, we just want to get into a line that has other water in it. That way the salt water can't solidify. If it sits up too long, there's a chance if it gets cold enough, it can re-solidify into salt crystals. But yeah, no, it's the same as produced water, and we're not making a lot of it. So you're not, most of our clients, they don't even notice, unless they don't make any water at all, they don't even notice that we're adding water to their tank.
Well, going into the case studies, let's talk on the top one and kind of go through there of explain these scenarios.
So the first one is, this is that Colorado application, right, Eric? Yeah, this was, I guess you can talk a little about this one. I think you actually visited this one, right?
No, I didn't get the chance to go to Colorado on that trip, but
Hey, we shipped you to Louisiana. I mean, it's kind of the same thing as Colorado. So.
Yeah.
oh yeah. I believe this is for a fuel gas, or was it a polishing unit?
This
I
was
don't
compressed
remember.
natural gas.
Okay.
So yeah, this was they were drying the gas that was coming off of a well. They had no pipeline, but they wanted to produce the well, so they're actually turning the gas into CNG. And they ran it for a couple months while they were waiting for their pipeline to get put in. So yeah, this was an interesting one to do. They need the gas clean enough to get in the CNG unit so that the CNG trailers didn't have water fallout or anything, and it would meet spec when they offloaded the CNG trailers into the pipeline miles away. But yeah, that was an interesting one. And then one of your guys has 2 other sites like that up in Pennsylvania, where
Yes.
we're cleaning it up for CNG gas. So yeah, those are interesting applications. The middle application, so that one used to be one of yours, Eric. That was over in Livingston.
Yeah, right in Goodrich, right just south of Livingston. Yeah, that's the TEG was failing, and they called and asked, do we have a PDS? And I think it was we had those 236s and a 16-inch separator there, and I think we had it ready to go. So in about a day or two, we had that unit out there ready to go. And again, actually they still use the contact tower as a separator before us, so they left the piping there, and then just from the outlet they shoot right over to us in and out. And I don't even know if that took an hour to get installed. That one went really quickly.
Yeah, and the picture kind of reminds me of another one, but the other one was in Louisiana, where they their glycol unit was operating so poorly that the cost in glycol per month that they were spending was more than our rental rate for the unit. And we see that a lot, especially on the smaller ones. We've had units that we've replaced where their increase in gas volume sales pays for the entire PDS system. So just not including filters or man-hour time or glycol or anything else, just the increase in fuel gas or in gas that was getting burned for fuel or going through the pumps because of bad pump or whatever, just that increase paid for the whole system alone. Normally that's on the smaller size, but the one in Louisiana, that was a decent size. It was like 2 million a day unit, and they were spending 3,000 or 4,000 a month in glycol because they were just losing so much out of that system. But yeah, the picture kind of reminds me of that one because their glycol unit looked terrible. But yeah, the last application, so that's a large processing facility where we were doing 60 million a day worth of gas. That was I'm trying to remember where exactly that one was.
That was West Texas.
West Texas, yeah. So yeah, that was another shorter term project where they needed to dry coming into the facility, and it was supposed to be, but due to pipeline issues, they had us out there to make sure that the gas was dry coming in the facility, so that we didn't overwhelm the emulsive dehy that was part of that facility, because the gas was supposed to be 7 pounds, and due to some upsets in the pipeline, it wasn't.
Well, I don't see any questions, and trying to wrap up and stay within our time frame because I don't want to get everyone upset because they're not eating lunch right now. But we're going to wrap up. If you're interested in being a webinar speaker or know of someone who would be a good fit, please reach out to us. Email tori.valagura@Croft Systems, so that way we can get you on, get you talking, or if you want to hear some other topics, please reach out to us. Give us feedback on what we're doing. We want to make sure that this information is coming across to the best of our capability so we can tailor our upcoming webinars. This is also a PDH credit. So if you would like a PDH professional development hour, please reach out to us so that way we can ship you that 1 hour certificate for this webinar. If you have any questions, concerns about what's going on or what we discussed here, you want to hear more information, please reach out to us. You can call us on our office line, info@Croft Systems, or you can find me on LinkedIn. And then if you need to talk to Gorka, Chris, please reach out to us, and then I'll make sure to yell at them for you. But I appreciate everyone joining us today, talking with us about emissions-free dehydrators. There's going to be more specific questions in the futures that we're going to go into. And then Gorka and Chris, thank you all for coming on board with us.
Oh, absolutely.
All right. Take care, guys. Thank y'all very much for everyone joining us.